Imagine an object the size of Manhattan, silently tearing into our solar system at an incredible 130,000 miles per hour. This isn't science fiction. This is 3I Atlas, only the third confirmed interstellar visitor to grace our cosmic neighborhood. But this visitor is different. It's not just another rock from a distant star. It's sparking a fierce debate among the world's top astronomers, a debate centered on a tiny, almost imperceptible clue: non-gravitational acceleration. This subtle deviation from its expected path hints at something pushing it, something other than gravity. And from this hint, whispers have turned into serious discussions about a possibility so profound, even experts are hesitant to say it aloud. Could 3I Atlas be a nuclear-powered reconnaissance craft? Is it following a pre-planned trajectory? One so statistically unlikely it has less than a 0.005% chance of occurring by random cosmic chance? The idea sounds like something straight out of a blockbuster movie, but the evidence, and the lack thereof, is forcing us to confront a question that could challenge everything we believe about our place in the universe. What exactly is moving among the stars? The first piece of this puzzle lies hidden in mountains of data, where precision is everything. The hunt for clues about 3I Atlas's acceleration isn't about wild speculation. It's a story of meticulous, painstaking work. Every single night, teams at observatories in Chile and Hawaii log the object's precise position against a backdrop of distant, unmoving stars. They record timestamps down to the millisecond. The powerful Atlas telescope, with its arrays of sensitive detectors, captures the faint streaks of light as 3I Atlas sweeps across the inky blackness. These raw images, combined with follow-up observations from the Pan-STARRS survey and even pinpoint snapshots from the Hubble Space Telescope, form the official dataset. This data is sent to the Minor Planet Center, the world's clearinghouse for all things small and moving in our solar system. From these thousands of data points, astronomers build a detailed map, an ephemeris, predicting exactly where the object should be, hour by hour, for weeks to come. The real detective work begins with what are called residuals. It is a simple concept. You compare where the object asterisk should asterisk be based on a pure gravity model, just the sun and planets pulling on it, and where at asterisk actually asterisk appears in the sky. Any difference, measured in tiny fractions of an arcsecond, is a residual. And if something other than gravity is pushing or pulling the object, it will show up as a clear pattern in these numbers. A slow drift, a sudden kink, a systematic offset that grows night after night. This is the smoking gun they're looking for. So, what have they found? The official orbit solutions from NASA, JET's Jet Propulsion Laboratory and the Minor Planet Center tell a clear story. So far, the object's observed track matches the predictions of a gravity-only model almost perfectly. The residuals show no persistent deviation, no unexplained acceleration at the millimeter per second squared level that rises above the statistical noise. In fact, when scientists tried to add a hypothetical thrust or a jet parameter into their models, it didn't improve the fit at all. The data, as it stands, aligns perfectly with a natural gravity-driven trajectory. Technicians and analysts, some pulling all-nighters, have cross-checked every calibration file and error bar. They've overlaid astrometric charts, comparing the predicted path with the observed one, searching for any hidden structure in the scatter of data points. Every outlier, every dot that seems out of place is scrutinized. Was it a cosmic ray hitting the detector? A faint background star mistaken for the object? A simple tracking glitch? Only after this exhaustive review did the final residual plots confirm the current verdict. The motion of 3I Atlas can be explained by the known gravitational influences of the sun and planets alone. But in science, the story is never truly finished. As 3I Atlas continues its journey, arcing closer to the sun, every fresh measurement from ground and space-based telescopes is run through the same battery of rigorous statistical tests. With each new observation, the margin for error shrinks, and the search for that elusive, subtle, thrust-like behavior continues. For now, the evidence for a propulsion signature is not just weak, it's absent. But in the world of interstellar mysteries, the very next observation could always rewrite the story. This very lack of evidence is what fuels the fire, splitting the astronomical community right down a familiar fault line. On one side, you have the camp that points to the classic, well-understood physics of comets. They argue that as 3I Atlas gets closer to the sun, volatile ices like frozen carbon dioxide or water on its surface will heat up and erupt into space. These asymmetric jets of gas would act like tiny natural rocket engines, nudging the nucleus ever so slightly off its purely gravitational course. In this view, any non-gravitational twitch we might eventually see can be explained by a pocket of gas bursting free, sending a faint plume into the void. The numbers support this possibility. For a comet the size of 3I Atlas, even a jet releasing just a few kilograms of gas per second, a tiny amount, really could easily account for the millimeter per second squared accelerations that some are looking for if they were to appear. The problem? The most recent data from photometry and spectroscopy analyzing the object's light show no strong evidence of such outgassing. Yes, there's a faint coma, a fuzzy atmosphere of gas and dust, but specific jets remain unresolved. The tail structure we see so far matches what you'd expect from simple sunlight pushing on dust particles, not from a directed propulsive force. This is where the other side comes in. A handful of theorists, most famously led by Avi Loeb of Harvard University, argue that this very absence of clear outgassing, combined with the object's brightness and highly unusual trajectory, leaves the door wide open for more radical explanations. Loeb has publicly floated the headline-grabbing possibility of a nuclear-powered propulsion system. He suggests that if 3I Atlas were an engineered probe, a gigawatt-class reactor similar in power to a terrestrial, nuclear power plant could theoretically produce the kind of subtle acceleration and luminosity that has been observed or hypothesized, all without expelling a large, easily detectable cloud of gas and dust. He points to the object's trajectory, which includes planned flybys of planets and the sheer statistical rarity of its path as circumstantial evidence. It's like finding a message in a bottle that not only washed up on your shore but also landed perfectly upright on your doorstep. It's possible, but it makes you wonder. The calculations behind this are bold, pushing the boundaries of known physics and engineering. A gigawatt of power being vented as heat or charged particles could create a tiny but persistent push. It's an extraordinary claim, and it requires extraordinary evidence. For now, it remains a tantalizing hypothesis, a what-if scenario that hinges on the absence of a conventional explanation. The debate rages on. Is it a simple gassy comet, or are we witnessing the flyby of something far more complex? The answer is still out there, waiting in the data yet to be collected. Thank you so much for joining me on this deep dive into one of the most exciting mysteries in modern astronomy. The universe is full of wonders, and it's incredible to live in a time where we can ask these big questions. What if I told you that a city-sized object, moving faster than any spacecraft we've ever built, just silently passed through our solar system? And what if I told you that some scientists believe it might not be entirely natural? This is the story of 3I Atlas, an interstellar visitor that's forcing us to question everything we thought we knew about the cosmos. First, let's talk about the sheer scale of this thing. Astronomers estimate 3I Atlas is nearly 20 kilometers or 12 miles from end to end. To put that into perspective, imagine the entire island of Manhattan, from Harlem to Battery Park, hurtling through the void at over 130,000 miles per hour. This isn't a small rock or a cosmic snowball. It's a city-sized mass, and its presence is so vast that even our most powerful telescopes struggle to see its true shape. So how do we even find it? The truth is, it was a mix of luck and constant vigilance. For most of its journey towards us, 3I Atlas was hidden in the sun's glare, a blind spot for many of our telescopes. Automated sky surveys like Atlas and Pan-STARRS, designed to spot dangerous asteroids, only caught the first glimpse of it when it was already deep inside our solar system. The initial images didn't show a clear, sharp object, but a fuzzy, glowing cloud, a coma of dust and gas that hid the nucleus within. It took painstaking work, digitally peeling away that cloud layer by layer, for astronomers to even begin to estimate the staggering size of the core hidden inside. The two previous interstellar visitors we've confirmed, Oumuamua and Borisov, were tiny in comparison. One was about the length of a football field, the other the size of a small mountain. 3I Atlas is in a completely different league. It's an outlier among outliers. The kinetic energy it carries is beyond anything we've ever recorded from a passing object. Thankfully, this giant was just passing through, indifferent to us, following a path set in motion long before human civilization even began. Now here's where the story gets really strange. This object isn't just moving fast, it's accelerating. It's moving away from the sun faster than gravity alone can explain. For most comets, this isn't unusual. As the sun's heat warms them, ice turns directly into gas, shooting out in jets that act like tiny rocket thrusters. But the amount of gas and dust coming off 3I Atlas seems far too small to account for the extra push it's getting. The numbers just don't add up. It's like seeing a sailboat moving quickly in a light breeze. Something else must be at play. This discrepancy has opened the door to a truly extraordinary idea. A small but vocal group of scientists, including Harvard's Avi Loeb, have proposed a radical theory. What if the extra thrust isn't from melting ice, but from an engine? They suggest that a low-power nuclear reactor on board could generate a gentle, continuous thrust enough to alter the object's path over weeks and months. This would explain the non-gravitational acceleration without the need for massive, visible gas jets. It's a mind-bending possibility. An alien probe, the size of a city, using advanced technology to navigate the stars. But extraordinary claims require extraordinary evidence. And this is where the scientific debate really heats up. NASA and the majority of comet scientists are highly skeptical. They argue that a nuclear engine, even a small one, would produce a detectable signature. It would emit intense gamma rays, neutrons, and a huge amount of heat. We have powerful observatories both on Earth and in space, like the Fermi and Swift telescopes specifically designed to look for these signals. And so far, they've found nothing. No excess gamma rays, no neutrons, and no unusual infrared glow coming from the direction of 3I Atlas. According to mainstream models, the object's brightness perfectly matches what you'd expect from sunlight simply reflecting off its surface of dust and ice. A nuclear drive powerful enough to move an object this massive would be incredibly bright in thermal and high-energy bands, outshining the reflected sunlight by orders of magnitude. The fact that we don't see this glow is, for most astronomers, a powerful argument against an artificial engine. But the mystery isn't completely solved. The coma of dust and gas, faint as it is, could still be masking small, subtle jets that our current telescopes can't resolve. We're still waiting on more detailed data from the James Webb Space Telescope, which might give us a clearer picture. For now, the evidence leans heavily towards a natural explanation, perhaps a very unusual, highly active comet unlike any we've seen before. As NASA's lead comet scientist put it, what we're seeing is consistent with a natural object, and the case for a nuclear engine just isn't there yet. So, where does that leave us? We're faced with a visitor from another star system, defined by its hyperbolic orbit path that guarantees it came from interstellar space and will never return. It arrived with a speed and on a trajectory that defies easy explanation. It's accelerating for reasons we can't fully confirm, and its sheer size challenges our understanding of what's possible. Are we witnessing the slow, uneven push of melting ancient ice, a natural process playing out on a colossal scale? Or are we seeing the faint, deliberate thrust of something built far from home, a silent traveler on an unknown mission? The debate sharpens with every new piece of data. The answer remains hidden in the faint jets and silent spectra of this incredible object. 31 Atlas is a profound reminder that the universe is far stranger and more vast than we can imagine, and that even the largest visitors can arrive in silence, leaving us to wonder what else might be out there, crossing the darkness, completely unseen. Hey everyone, and welcome back. Today, we're diving into a story that feels ripped straight from science fiction, but it's unfolding right now in our cosmic backyard. We're talking about an object named 3I Atlas, a visitor from interstellar space that is not just passing through it, as taking a grand tour of our solar system, and its path is raising some mind-bending questions. So what makes 3I Atlas so special? It's on what astronomers call a hyperbolic escape. Imagine throwing a ball so hard it never comes back down. That's essentially what this object is doing. It arrived in our solar system seemingly out of nowhere, with no gravitational slingshot or rocket engine to explain its speed. Once it completes its arc around the sun, it's gone for good. There's no invisible leash pulling it back. Its speed, even after fighting the sun's immense gravity, is so high that it has a one-way ticket out of here, destined to vanish back into interstellar darkness. To picture this, think of our solar system as a flat disk with planets orbiting in circles. Most comets and asteroids follow these looping paths. But 3I Atlas is different. Its trajectory slices through this disk like a spear. The sun's gravity bends its path, but it can't capture it. Even Jupiter, our solar system's heavyweight champion, can only give it a slight nudge. This creates an incredibly fleeting opportunity for us. 3I Atlas will spend just a few months inside the orbit of Mars and only a handful of weeks near Earth just distance from the Sun. After that, it accelerates away, forever leaving our cosmic neighborhood. This isn't just a technical detail. It defines the urgency for scientists. Every single observation, every image has to be captured before this window closes forever. There are no second chances. The very same math that tells us this object IS&T from here also guarantees it will never pass this way again. For astronomers, the clock is ticking, and the data they collect will shape our understanding of these mysterious interstellar visitors for decades to come. But the hyperbolic escape is just the beginning of the mystery. The real head-scratcher is asterisk where asterisk it's going. The path of 3I Atlas reads like a meticulously planned cosmic itinerary with scheduled flybys of multiple planets. On September 30th, 2025, it will pass within 13.9 million kilometers of Mars, close enough for our orbiters there to get a good look. Just 2 weeks later, on October 14th, it makes its closest approach to Earth, skimming by at 27.5 million kilometers. That's well beyond the Moon, but it's the closest any interstellar object has ever come to us. The tour doesn't stop there. On November 2nd, it zips past Venus. Then it swings out towards the gas giant Jupiter, reaching its closest point on March 8, 2026. Each of these flybys is a fleeting chance to study this object. A chance that will never be repeated. Now here's where it gets truly strange. The sequence of these flybys, Mars, then Earth, then Venus, then Jupiter, is incredibly rare. The object's path is almost perfectly aligned with the plane of our solar system, but it's traveling in the opposite direction. Orbital analysts have run the numbers, and the odds of an object randomly taking this exact tour are less than 1 in 20,000. That's a 0.005% chance. A number that low has fueled intense scientific curiosity and, you guessed it, a lot of public speculation. This isn't a collision course. These are measured passes. Close enough for detailed study, but far enough to avoid getting captured by any planet's gravity. For scientists, each flyby is a unique opportunity. Mars orbiters can scan it for dust. Earth-based telescopes can track its coma. The flyby of Venus offers a different angle for infrared imaging. And Jupiter's immense gravity provides a final test of its trajectory. The choreography is stunning. No other interstellar object we've ever seen has traced such a path. For some, it hints at reconnaissance, a deliberate pattern. For others, it's just a statistical fluke, a rare but natural cosmic coincidence. What is certain is that the journey of 3IATLAS is one of the most improbable tours ever recorded in the history of astronomy. This improbable path is where the argument for something. Asterisk more asterisk gains its sharpest edge. This isn't just about speed or size. It's about the way 3I Atlas threads the needle of our solar system with what looks, on paper, like tactical precision. Think about it. The flyby sequence isn't just rare. It's geometrically efficient for observation. As it passes Mars, the red planet is almost perfectly illuminated, its features exposed. 2 weeks later, Earth is positioned for a fantastic view, closer than ever before for an interstellar visitor. Then Venus, with its bright, reflective cloud tops. And finally, Jupiter, with its swirling storms ready for a close-up from a unique angle. Prominent astronomers like Avi Loeb point to these alignments as more than just a happy accident. He suggests we should consider the logic of reconnaissance. If you were sending a probe to survey a planetary system, you would optimize its path for maximum data collection with minimum risk. The geometry here is striking. Each approach seems timed to exploit the best viewing angles, while the high-speed exit ensures a clean getaway. Again, the odds of this happening by chance are staggeringly low. If this path was engineered, it reflects a level of planning that rivals our own most sophisticated planetary missions. Of course, skeptics argue that the solar system is a busy place, and given enough time and enough objects, even the rarest alignments will eventually happen. But the combination of a multi-planet tour on a high-speed retrograde trajectory remains a profound statistical outlier. The question isn't just whether 3I is a natural object, but whether its path is optimized for observation in a way that random chance struggles to explain. As the debate continues, the sheer geometry of this encounter forces us to weigh the possibility of intelligent design against the long odds of a cosmic lottery. Each pass of 3I Atlas through our solar system raises an unsettling question. Are we witnessing cosmic chance, or does this trajectory hint at intent? Its path skimming Mars, Earth, Venus, and Jupiter feels more like a survey than a random drift. This is where a fascinating and somewhat chilling idea from cosmology comes into play: the dark forest hypothesis. This theory imagines the universe as a silent, dangerous wilderness. In this forest, survival depends on staying hidden. Any civilization that reveals its existence risks attracting predators and being destroyed. So, if an advanced intelligence wanted to observe other worlds without being noticed, how would they do it? They might send stealthy, silent probes that gather data from multiple targets and then slip away quietly, leaving behind nothing but questions and a trail of unbelievable coincidences. This brings us back to Oumuamua, the first interstellar object we ever detected, back in 2017. Its bizarre, cigar-like shape and its unexplained acceleration as it left our solar system sparked a firestorm of debate about whether it could be artificial. Avi Loeb, the same astronomer questioning the path of 3I Atlas, was at the center of that debate. He sees a potential link, a pattern of strange visitors. First, an object that accelerated without a visible cause. Now, an object on an impossibly precise tour of our inner planets. Could 3I Atlas be another piece of that puzzle? A second data point in a mystery that's just beginning to unfold? We are in a truly unique moment in history, where technology has finally allowed us to spot these fleeting visitors from other star systems. But what we're finding is challenging our assumptions about the universe and our place in it. Whether 3I Atlas is a natural comet on a lucky streak or something far more extraordinary, its journey is forcing us to ask bigger, bolder questions. We are watching, and perhaps, just perhaps, something is watching us back. What do you think? Is this an incredible coincidence, or is it a sign of something more? Let me know your thoughts down in the comments. Imagine an object, the length of a football field, silently gliding through our solar system. That was Oumuamua in 2017. It left us with more questions than answers. Now, fast forward just 8 years and another visitor appears, 3I Atlas. This one is 20 times larger, tracing a path through our cosmic neighborhood with stunning precision. This 8-year gap between interstellar visitors is fascinating. Some, like renowned astronomer Avi Loeb, suggest this timing might not be random at all. Could it be a deliberate sequence? First, a scout, then a more capable probe. Each pass, a test. Each encounter, a chance to observe our reaction. The implications of this go far beyond typical astronomy. If 3I Atlas is more than just a comet, if it's a messenger or a watcher, we're suddenly dealing with existential questions. Behind closed doors, SETI groups and security analysts are quietly debating a critical choice. Should we respond, or should we stay silent? These discussions, though rarely made public, reveal a deep split between curiosity and caution. There's the dark forest theory, which urges silence. It paints a picture of a universe where every civilization is both hunter and hunted, and discretion is the only true safety. But the human desire to reach out, to connect, is powerful. As Loeb puts it, if this object turns out to be technological, it would have a massive impact on humanity's future, and we would have to decide how to respond. Each interstellar visitor becomes a mirror, reflecting our greatest hopes and deepest fears, reminding us that in the vast, dark expanse, every light could be both an invitation and a warning. So, what does the science actually tell us? Telescopes around the world are pointed at 3I Atlas, collecting every photon, every scrap of data. As it entered the outer solar system, its coma, a glowing envelope of gas and dust, was already visible. This was a surprise. At that distance, sunlight is incredibly weak, and most comets are still frozen and dormant. Spectra analysis from ground-based observatories and even the James Webb Space Telescope has revealed an unusual chemical signature. The coma is dominated by carbon monoxide, with a ratio of nearly 8 parts carbon monoxide to 1 part water. This is the complete opposite of most comets in our solar system, where water is the main ingredient. This strange chemistry suggests 3I Atlas was forged in a much colder, more distant part of another star system, where carbon monoxide ice could survive for billions of years. What about its brightness? Photometric models, which estimate how reflective an object is, place 3I Atlas among the brighter comets we've seen at such distances. But it's not so bright that it defies natural explanation. Its brightness is consistent with a large, active comet, not some engineered, hyper-reflective alien craft. Imaging campaigns are tracking the evolution of its coma and tail. The tail stretches for millions of kilometers, pointing away from the sun, just as you'd expect from solar radiation pushing dust outward. So far, there's no evidence of strange, focused jets or unnatural emissions. The catch is its distance. At its closest approach, it was still over 167 million kilometers away, making it incredibly difficult for even our best instruments to resolve fine details. Skeptics in the planetary science community see all of this as strong evidence for a natural origin. The chemical makeup, the brightness, the classic tail, it all fits the profile of an interstellar comet, even if it's a bit peculiar. Scientists are still searching for any anomaly, unusual light polarization, excess heat, or spectral lines that could hint at something engineered. But for now, the evidence weighs heavily on the side of nature. The race is on to capture every last piece of information before 3I Atlas disappears back into interstellar darkness, taking its secrets with it. Objects like 3I Atlas don't just puzzle astronomers. They challenge engineers. The moment it was discovered, mission planners at NASA, ESA, and private think tanks started running the numbers on a potential intercept mission. The results? They're sobering. 3I Atlas is screaming through our solar system at 61 kilometers per second. That's over 136,000 miles per hour. To catch it, we'd need to launch a probe on a one-way sprint, burning through fuel at record-breaking speeds. Project Lyra, a team of propulsion specialists, has modeled this exact scenario. Their conclusion is that a direct launch from Earth, even with our most powerful rockets like the SLS or Starship, is simply not possible. They just don't have the required delta V or change in velocity to catch up. The only viable option, at least on paper, is a daring solar orbit maneuver. You launch a probe towards Jupiter, use its gravity to slingshot back towards the sun for a hair-raising dive, and then fire the engines at the closest point, where the sun's gravity gives you a massive speed boost. This sequence squeezes every last drop of energy from the propellant, but it relies on technology that is right at the edge of our current capabilities, and the clock is ticking. By the time 3I Atlas was identified as an interstellar object, precious months had already been lost. Project Lyra's charts show that every week of delay adds kilometers per second to the speed requirement, shrinking the possible payload from the size of a refrigerator to a suitcase and finally to a shoebox. The launch window for this kind of intercept mission closes by early 2026. After that, it's gone, too far and too fast for any mission to catch. ESA's Comet Interceptor mission offers a glimpse of a different strategy. It's a spacecraft currently waiting in space for a suitable target to fly by. While it wasn't designed for the insane speeds of an interstellar visitor, its philosophy is the new rallying cry: be prepared, stay flexible, and strike when the opportunity arises. The lesson from 3I Atlas is crystal clear. To meet the next interstellar arrival, readiness must be the default. We need mission kits propositioned, propulsion systems tested, and launch protocols streamlined. Because the moment a new object is detected, the countdown begins, and every hour lost is a monumental challenge to overcome. The chase for 3I Atlas isn't just a race against celestial mechanics. It's a test of how quickly we can turn scientific urgency into real-world action. This brings us back to the ultimate question: what do we do? On one side of the debate, you have those who point to decades of cosmic silence from our radio telescopes. No confirmed signals, no galactic chatter. They bring up the dark forest hypothesis, warning that broadcasting our existence could be like shouting in a jungle full of hidden predators. Silence is survival. On the other side, many see the arrival of 3I Atlas as a fleeting, perhaps once-in-a-generation, chance to make contact, to announce our presence, or at the very least to dip our toes in the cosmic water. They argue that if this is a probe, it probably already knows we're here. Silence might be pointless. There's no consensus. The debate rages on, even as the window for any kind of action closes. Both sides are looking at the same facts: the object's rare trajectory, the lack of direct evidence for alien technology, the immense potential risks, but they are drawing opposite conclusions. In the end, we're left staring into the unknown, asking a fundamental question: is it wiser to speak or to listen? The stakes aren't just about collecting data. They're about the kind of future we choose to create for ourselves. As of today, critical information remains limited, and some details are even classified. Whether 3I Atlas is a natural wanderer from a distant star or something more, its passage through our solar system is a profound challenge. It's a call for humanity to prepare, to observe with our best science, and to think deeply about our place in the cosmos. Thanks for joining me on this journey to the edge of our solar system and beyond. If you found this as fascinating as I did, make sure to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next exploration into the great unknown. See you next time.